polynomial function is something that you learned back all the way in Algebra 1, maybe even before then, but definitely Algebra 1. And I kind of I shortened the book definition, but this is the way the book writes a polynomial function. And this is kind of really small, but that's an n, like a sub n, x to the n, plus a sub n minus 1, x to the n minus 1. And it just goes dot, 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 all the way down to just a constant. And that's how we write polynomials. But here's the big definition here. And this is a lot of math talk here. A has to be a real number, which means A can be anything but imaginary numbers to be a polynomial. More importantly, n has to be an integer. What is the definition of an integer? Or maybe what could you tell me is not an integer? Well, we wrote this out in last chapter too for when we were doing horizontal asymptotes. This just means n is the highest exponent. A sub n means the number in front of it, it goes with it. And then as we go down, normally the exponents go down by 1, right? So if this was x to the 4th, this would be 4 minus 1, or x to the 3rd, and then x squared, and then x, and then nothing. So just like the math definition of that is they just kind of throw those letters in there to say this is the coefficient in front of this one, this is the coefficient in front of that one. But it's not really that, like, don't stress about that definition very much. Because I could throw some numbers in there, like 4x cubed plus 2x squared minus 3x plus 1 is an example of something that fits that model. Because I start with, this would be my n, so it would be n minus 1, that would be n to the first, that would be 0 power there, a to the 0. What I want to know is what are my restrictions on polynomials? If n has to be an integer, what can't I have in the exponent part? An integer, yeah, integers really do include negatives, but you're right, we can't have negative exponents there. All right, let's write this. No negative exponents. Integers do not include fractions or decimals, so that means you could never have a fraction or a decimal in your exponent if it's a polynomial. So an example of that would be like x to the 4/3 power. That's not a polynomial. You also can't have any, well, I don't know. I think that's about it. That's kind of what we're looking for there. And then we also talked about this already once, but remember that the highest degree, the number in front of that is your leading coefficient. Part of your homework today is just like homework that we did in Algebra 2, where you just get to say, is it a polynomial, and what's the leading coefficient? Which isn't so bad to do. We deal with a lot of things that aren't polynomials. Part of our 10 functions are not polynomials, but right now we're just focusing on polynomials. So let's do a few of these in practice to make sure we know what a polynomial is before we jump ahead here. And I'm just going to show you all 3 of these. I'll let you write them down, and then we can go through and see if we think, is it a polynomial function? If so, state the degree and the leading coefficient. And if you remember anything about graphing these last year, the degree and the leading coefficient tell us a lot of things. It tells us about the graph. It tells us about the number of zeros. And so that's why degree and leading coefficient is so important. So my first one there, f of x equals -9 plus 2x. Is it a polynomial? Are there any negative exponents? Are there any fractional exponents? Anything crazy going on in there? No. negative 9 and 2 are real numbers. X to the first power, that's an integer. So it is a polynomial. I'm just going to write LC for leading coefficient if you're okay with that. Leading coefficient. What's the degree? 1, the highest exponent. That's easy. The leading coefficient, the big mistake people make on this is they just take the first number, or sometimes they take the biggest number. The leading coefficient is the number attached to where that highest exponent is. So if the highest exponent's here, the leading coefficient is the one right next to it, which we would say is 2. We all remember this? What about this one? 13. Is that a polynomial? There's no negative exponents. There's no exponents to weird powers there. We could think about, if I wanted to put an x in this, what would the power be on that? Because x to the 0 is just 1. And so that's just a straight line. It is a polynomial function. We don't think about it being a polynomial function because it's just a number, but it really is. I wanted to throw that one in there because sometimes people get tricked by it. And I kind of helped you out, I think, with the degree already. What's the degree of this one? 0? Because there is no power there. So can we say the leading coefficient is 13? Technically, that's the only number that we have there. What about number 3? There's no negative exponents in there. There's no fractional exponents in there from the way it's written, right? It's a trick, isn't it? What is this? Could I rewrite this so that the x was in the top? Yeah, if I move this up, isn't this the same as saying x to the negative 1 power? So when there's a letter in the bottom, that's the same as having a negative exponent. And so maybe if you want to add to that list back here, no fractions, decimals, no negative exponents, no letters, variables in the denominator, because that is a negative exponent, it means the same thing. So this one is not a polynomial, so I'm just going to put no there. So if it's not a polynomial, it can't have a degree, it doesn't have a leading coefficient. That's first part of your homework. Not so bad, right? The second part of your homework throws in some linear stuff, and I want to do an example of this because every year people get thrown off by it if I don't do an example. Oh, actually, wait a minute. I have this one. This is for you to do. Don't yell the answer out. This is a little check to see if we understand polynomial functions. Under your desk, you have a little board with a marker on it. I want you to tell me which of these is a polynomial function and write your letter down and hold it up so we can make sure that we all know what a polynomial function is. You can erase it. I don't know who did it. I need to yell at them. Sorry, just erase it. There you go. You can just like it's a message to you.
No regrets. Add to it. Say no.
Will you just erase it and write your letter down? Everyone's right. So far they held up. So a little check for understanding. Everyone's a big picture on here. I need it. My party time is on Tuesday. Tuesday pictures on them. I have the other. Anybody else? What did you decide your answer?
I haven't decided yet. You actually yelled at it?
Yes, because these markers cost money. So when you waste all my markers, whatever is inside of markers, and then my marker dries out because you're drawing pictures on my board, I yell at them. Say, don't waste my markers.
What
Just
grade
erase
do you
it.
have?
Sophomores. It was someone I yelled a lot. C is the right answer, right? Look for things that are x's in the bottom, negative exponents. What's wrong with this one? It's a square root, and although it's under there, we can't really take it out of there. If you you have a square root, remember that's kind of like the 1/2 power, so that's a fractional exponent too. And so that's why C is the right answer. I feel like we're pretty good at that. All right, let's look at this one. It says write an equation for the linear function f such that f of -1 equals 2 and f of 2 equals 3. Yeah. And it's nice because they tell you what kind of equation you should be writing. A linear equation. So do we have a form for a linear equation that we usually write linear equations in? Yeah, we have y equals mx plus b. We're going to do this almost with every type of function that we talk about. We can do it with quadratics, we can do it with conic sections. If they give you some information and you have the form of the equation, you should be able to write that. The next part is remembering what this means. And I can tell you that in calculus this year, we've had some issues with function notation here. What does this mean? F of -1 equals 2. What is the -1 telling you? What x is, and when x is -1, what is it telling you that y is? 2. It's just another way of writing an ordered pair. Function notation, this is saying when x equals -1, y equals 2. The reason math people use function notation is it's much shorter to write this. So this is like the ordered pair, -1, 2. And they're giving you another ordered pair. If f of 2 equals 3, that means when x is 2, y equals 3. If I give you 2 points, can you write a linear equation? What do you need m and b? What does m represent? Slope. And can you find the slope if you're given 2 points? How do you find slope? Rise over run, right? So we subtract the y's on top. X is on the bottom, so you can find the slope. So I'm going to go 3 minus 2, y minus y, over 2 minus -1. So that's going to change to 2 plus 1. And I think I get 1/3. That's my slope. Do you agree with that? Now you need to write the equation. There's 2 ways to do this. Most people remember y equals mx plus b, and that's what you're going to use. We also have another form of the equation called point slope form. I like it much better. I'm going to show you that in a minute. But if I know my slope is 1/3, in this form I still need to find b. What does b represent? The y-intercept. Some people say, well, I could make a graph, and then I could just see where the y-intercept is, and I could figure it out. That's true, but what if your y-intercept is a fraction? It's going to be really hard to tell that from the graph. So algebraically, do you remember what I can do here? How can I find b if all I know are these points up here? Do I need to plug both of them in? Yeah, pick whichever point you want, plug it in for x and y, and solve for b. Right? You've been doing this for years. It doesn't matter which one you pick. I'm going to pick 2, 3, just because I'm not going to pick a negative. So I'm going to plug in 3 for y and 2 for x. I promise if you plug in -1, 2, we're going to get the same answer. You definitely can use a calculator, but 1/3 times 2 is just 2/3. And I subtract 2/3 over. I think that's going to be like 2 and 1/3. But if I'm going to do it as an improper fraction, that would be a common denominator of 3. So that would be 9/3 minus 2/3 would be 7/3. It's okay if you just give me 2 and 1/3. So my equation is plugging that in. So I get y equals 1/3 x plus 7/3 or 2 1/3. I just want to throw out there that it doesn't say you have to put it in slope-intercept form. And if you have a point and you have a slope, point-slope form is really easy, especially if you don't have to simplify it. So I just want to give you this one just to remind you. This is called point-slope form. I never appreciated point-slope form until I taught calculus, because we write linear equations all the time in calculus, and you don't have to simplify them, which means all you have to do to write this equation is plug in one of those points for x1 and y1 and plug in your slope, and you don't have to do any work to simplify it. So you could say y minus 2 equals 1/3, because that's my slope, x minus -1. And if you simplify that, you're going to get the same thing as this. But since it doesn't say you have to simplify it, I would have to count that right and not make you do any work. You could do the same thing with this point. You could say y minus 3 equals 1/3 times x minus 2. And again, you don't have to simplify it. So just throwing that out there, that if you know this equation, you don't have to do as much work when you're doing these problems. So not trying to persuade you or anything, but it's kind of a nice thing. So polynomials, I feel like isn't so bad to do. This isn't so bad to do. The other thing we're going to talk about again is quadratics, which again isn't brand new. It's my last topic here. Vertex form of a quadratic equation. We talked already about quadratic equations, about graphing them. Back in chapter P, when we had that quiz, we talked about the quadratic formula. We talked about factoring. But what we haven't talked about this year that we talked about last year in Algebra 2 was the vertex form of a quadratic equation. This is what we normally think of. This is standard form. This is what we use when we're factoring and when we're doing the quadratic formula. But it's not that easy to graph in this form. Like normally you have to just make an XY chart or do some really ugly stuff. If it's factorable, yes. But if you write it in vertex form, it makes graphing really easy, and it makes using those transformations really easy. And so this is what we think about when we think about vertex form. It's a times x minus h squared plus k. X and y just stand for x and y, like always. But h, k, and a have very important features. And if you just want to write vertex h, k, you could. When you graph that, if it's in vertex form, the vertex will always be h comma k. So you don't have to do a lot of work to find that starting point. Because if you can find that vertex, you know every other point is going to be the same on either side, so it makes it really easy to graph. In A, if you think back to our transformations, whether A is positive or negative is going to determine whether that parabola opens up or down. Axis of symmetry is at x equals h. That's the line that cuts the parabola in half. We don't really use that as much, but this is kind of important. If A is positive, that's going to be a positive x squared, and so your parabola will always open up. And if A is less than 0, or if A is negative, then that parabola will open down. Part of your homework today, they give you a bunch of equations in vertex form, and they give you a bunch of graphs, and they just want you to match them up using the fact of looking to see whether A is positive or negative and looking at the vertex. Like, you shouldn't have to do work to do those problems. The part that we're going to focus on mostly is what if it's not in vertex form, how do we put it in vertex form? Because if it's already in vertex form, it's not that bad for us to do. So let's look at a couple examples. There you go. So I just want to show you how easy it is to graph these when it's in vertex form. There's not much graphing on your homework today. Like I said, you have to match, and I think there might be 2 or 3 that you're going to graph. But this one says describe how to transform x squared into the graph of 2 times x minus 2 squared plus 3. And then graph it. One, if you know those rules for transformations, then you can use that to help you. And also you can use what we know about vertex form to help us as well. What does a number outside of the function added to it mean it's going to do to the graph? What does plus 3 on the outside mean if we're thinking about transformations? It's going to mean a vertical shift up 3. And what does minus 2 on the inside mean that we're going to do? Go to the right 2. That's exactly what vertex form is giving us. It's giving us that new vertex. It's telling us that normally x squared starts at 0, 0, but we're going to go to the right 2 and up 3, and that's going to be our new vertex. So I could put moves right 2 and up 3. Notice if you do the vertex for that, if you take out h and k, remember last year, h is always the opposite sign of what's in there because it's x minus h. So the vertex is just 2, 3. It's exactly what that transformation would be. Is this one going to open up or down? So right here tells you, because this is positive, it's going to open up. But also, think about a number multiplied in front. It's going to actually change that graph a little bit. It's going to be stretched by a factor of 2. And so again, if you think about how we did this before, if you don't want to make an xy chart, normally for x squared, when I go to the right or to the left 1, how many do I go up? 1. If I'm stretching it by 2, when I go right, I'm going to go up 2 instead of up 1. If you don't like doing it that way, you can always make an xy chart. Pick the points right next to your vertex, and that will always give you those other points. So if you pick 1, you're going to get 2 plus 3, which is 5. If you don't want to do the other way. If you pick 0, again, if you want to think about it, normally when we go over 2 for x squared, how many do we go up? 4. On this one, since we're multiplying by 2, when I go over 2, how many are going to go up? 8. So that's how you can do it without actually making an xy chart. But I think we would get negative 2 squared, 4 times 2 is 8, plus 3, I think we get 11 here. So that would be like way up here. Remember the great thing about a parabola is that it is symmetric. So if I know this is at 11, I just flip it over and that's at 11 too. And obviously you didn't have to go to 11 on your graph, but that would be an easy way to sketch those graphs. That's why we like vertex form, because we can use those transformations to do that. So then the algebra part is, what do we do if it's not in vertex form? Most of your homework is this, practicing putting things in vertex form, and then you state the vertex and the axis of symmetry. So I'm going to just write the vertex form again. F of x equals a times x minus h squared plus k. When you look at this problem, it's not a perfect square, right? X minus h squared. So what do we have that we know how to do? How do we take something that's not a perfect square and turn it into a perfect square? Hint, it has the word square in it. Half of the middle number, right? What's that called? When you completing the square. In order to change this into vertex form, you're going to have to complete the square. That's the only way that we have of making something into a perfect square. Keeley says we're going to add 5 over, and that's what we do when we're solving something by completing the square. But there's a problem with it on this. If I add 5 over here, do I ever have anything over here with f of x? I don't. So when we complete the square on these, remember that we kind of just kick the 5 out to the end and we keep it all on the same side? So instead of adding this 5 over, I'm just going to group together the x squared and the 4x. I'm going to leave my spot to complete the square, and I'm just going to kick that negative 5 out to the end because I'm not allowed to add it to the other side. Also, think about, that's kind of a good thing that we have a number out there because that's going to be our k value too. But then you are going to complete the square the same way we've always done it. We're trying to come up with what number would make this into a perfect square. It works out really nice. It's always half of this number squared. So what is half of 4 squared? Half of 4 is 2, but then 2 squared is 4. Right? And again, what did we do back in chapter P when we were solving these equations? If I add 4 to this side, we had to add 4 over here as well, right? To keep it balanced. But again, there's a problem. I can't add anything over there. So if it helps, you can think about I add 4, but I need to move it back over. So what do I need to do to keep that 4 back over here? You subtract it on the outside. And we did this last year, and people really hated it. And you said, why would I add 4 and then subtract 4? Well, that's because I'm keeping it balanced. If I'm not allowed to do add 4 here and add 4 here to keep it balanced, if I add 4 here, how could I keep it balanced? I could subtract it back out. And so it's all about balancing that equation when you do that, without changing that f of x over there. Have vague memories of this from last year? We did a lot in those conic sections too. That's the hard work. Now we're just going to simplify it. Every time if you do this correctly, you should be able to write this as a perfect square. Simplify what's out here. Negative 5 and negative 4 make negative 9. And what do I get in here? It's always half of that middle number. So half of positive 4 is positive 2. So I get x plus 2 squared minus 9. And if you really did FOIL that all out, you would get back to that original problem. No, well, the formula is x minus. This is going to affect our vertex. That's a good question. So, Logan, I need to know what the vertex is. And if normally the formula is x minus h, what does that mean h is if I have a plus sign in there? Yeah, I think it's going to be negative 2, right? Remember that it's always the opposite of what's in there. This is like saying x minus negative 2 squared, but we don't really write it like that.
So half of 4 is 2, so I would put in the equation x minus 2 squared minus 9, because that's the picture.
No, because when you're doing this, when you're factoring this, you can't put minus 2 there, or that's not going to be a plus sign. You have to factor it the same way we've always factored it. The only reason that it's a plus sign is because the vertex is actually a negative number. The vertex is at negative 2, negative 9, not positive 2. So if your x value is negative, if your h is negative, this is always going to be a plus sign in there. Because when you subtract a negative, it's going to change into a plus sign. Axis of symmetry is the line x equals negative 2. Right, it comes from the vertex. This is h, this is k. We wrote this out. Hopefully you wrote that out. Axis of symmetry is the line x equals h, which is the line that cuts right down through your vertex. So it's always whatever h is. We got to look at one more example, because what happens if there's a number in front? And we might not work through this whole thing, because I hope that maybe we remember this from chapter P. Are you allowed to complete the square when there's a number in front of x squared? If this equation was equal to 0, like when we were solving these, we would divide everything by 2 first. Am I allowed to divide f of x by 2? Right, you have to factor it out. You cannot divide this, but you still need to get rid of it. And the only way you can get rid of it without dividing would be to factor it out of those 2 first terms. Not out of the 7, because the 7 we're kicking to the end, but I'm going to take a 2 out and get x squared plus 3x and kick that 7 to the end. so pretty, but we're going to take half of 3, which is 3 halves, and we're going to square it, which I believe would give me 9/4. And if I add 9/4 on the inside, I'm going to subtract 9/4 on the outside. But, does anybody remember what else we have to do to keep it all balanced? Yeah, this is really not just 9/4 because it's really 9/4 times 2. So you have to also multiply whatever you subtract out there by that number in front. We didn't have to do that on the first example because there was a 1 out there, not a 2 out there. I'm going to give you your assignment because I know the bell's going to ring, but then you just do the same thing there. We'll do a couple more of these tomorrow. I'm sure we'll have some questions on them.
So when you go to factor that, would it be x plus 3 halves?
Yes. Is the middle number a plus? Yes. It's always what the middle number is. Like, you're focusing on the fact that the formula is x minus h, right?
And on the outside, you have to multiply everything by 2 or just the negative?
Just the negative 9 minus. Here's your new assignment sheet. We are only doing half of this chapter before we have a test, so notice that there's only 4 sections, but those 2 lines means there's 2 days. So notice today you're only doing that first line, and then tomorrow, day 2, that's where the 45 to 48 come in. So you just do that first line today. That's day 1, day 2 tomorrow.
I need to find Jim.
Keely, did you just prove your homework needs to be
That lamb